Alright, so for today's lesson we're going to take a longer look at circles. And you may have never seen a formal definition of a circle, but what it actually refers to is a set of all points equidistant from a fixed point. So what does that actually mean? So equidistant, if you think about what it means, just breaking that down, equi means equal, distant means distance. It's looking for a set of all the points that are the same distance from a fixed point. Now, in a circle, what's that fixed point that all the points are going to be the same distance from? Well, it's going to be the center. So in some circle here, we're going to call the center, we're going to put it here, and we're just going to call the coordinates h and k. So again, h being the x-coordinate, k being the y-coordinate. And what the equation of a circle is going to describe is a set of all the points. So any point that's on here on the outside of the circle, we're going to call xy. And it's going to be equidistant away, and that distance away from the center to a point on the circle, as we know, is called the radius. So the question is, well, how can we actually describe the equation of a circle? Well, one thing that we can do, if we think about trying to describe the distance from going from the center to a point xy on the outside of the circle, remember last lesson we did look at the distance formula. So distance between any 2 points, x1, y1, x2, y2, will be d would be equal to the square root of the change in x squared plus the change in y squared. So what we can actually do in this case, if we want to try and describe the distance between the center and a point that's a random point that's on the circle, we can take a look at what's happening to the x values, what's happening to the y values. So looking at my x values here, I'm going from h to x. The distance from h to x will be x minus h. Okay, looking at the y values here, my distance from k to y will be y minus k. So using Pythagorean theorem, I can actually create an equation for a circle here. So r squared is going to be equal to x minus h squared plus y minus k squared. And what this actually does is it gives you a description for the equation of a circle. So looking at this, remember that h and k are going to be the coordinates of wherever the center of the circle is. Okay, and r is going to be your radius. So as long as you have the radius and you have the center of the circle, you can create an equation that will describe how the x and y variables are related to each other. Okay, so let's try and put that to use. So let's take the equation of the circle right over here. And with that in mind, let's try and determine the equation of the circles for all these different types of situations. I'll do the first couple with you, then leave the last 2 with you to try. So first off, we have one that's centered at the origin with a radius of 2. So if it's centered at the origin, the center is at 0, 0. The radius is 2. So putting that down here in this equation, we're going to have x minus 0 squared plus y minus 0 squared equals 2 squared. So simplifying inside the brackets here, x minus 0 is just x, y minus 0 is just y, so you get x squared plus y squared equals 4. So that should be the equation of our first one. Okay, let's try the next one quickly, just to get an idea of how it works. So now we're centered at negative 4, 7, so we have our h and our k. And our radius is 5. So what we're going to have here is x minus negative 4 squared plus y minus 7 squared equals 5 squared, r squared. So again, just simplifying, we're going to get x plus 4 squared, because x minus negative 4 is x plus 4, plus y minus 7 squared, and 5 squared is 25. So we get the equation of a circle. Okay, so what I'd like you to try and do now is try to do the last 2 on your own. And again, just see if you can create the equation of a circle for each of these. Okay, so let's check your answers here. So in this case, for C, the h value is 0, the k value is negative 8, so you get x squared plus bracket y plus 8 all squared. The radius is 2 over 3. When you square 2 over 3, 2/3 times 2/3 is 4/9. So we get x squared plus bracket y plus 8 squared equals 4 over 9. For D, the center is at 5, 2, so we get x minus 5 squared plus y minus 2 all squared. Square root of 53 all squared is 53. So again, we get that equation of the circle there. Okay, so a lot going on here, but again, once we get used to the general form of the circle, it's just a matter of subbing in your key points there. You have your circle, and you have, your center of the circle, and then you have your radius, which is really all you need to create the equation. Okay, so now we're going to look at a couple of examples here. So for each of these three examples, I'm giving you the equation. You're going to state the center, you're going to state the radius, and we're going to find four other what we call key points in the circle. Then those 4 key points, I'll show you how to find them, are going to help us make a nice accurate sketch. And once that's done, we're going to create the x and y intercepts, or sorry, calculate the x and y intercepts for each of these circles. Okay, so let's do the first one together. I'll move all this other stuff out of the way. Okay, now looking at the first one here, we have x squared plus y squared equals 9. So first off, let's just try and figure out where the center and the radius are. So in this particular case, the center is at 0, 0. And since we have 9 on the other side of the equation, remember that's equal to the radius squared, which means the radius itself is actually equal to 3. Okay, now to find our key points, if I was just trying to make a quick sketch here, I have my center at 0, 0 over here on the graph, and my radius is 3. So I can find other key points of moving at a distance of 3 in any direction from the center. So the easiest way to do that is to move from the center up 3, right 3, down 3, and left 3. So up, down, left, right, the amount of your radius. So if I do that over here, I'm going to have a point on the circle here, 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 and here. And these key points will help us create the sketch that we're ultimately going to use when we want to make a graph of the circle. So in order to find these points, I'm going to take my center, 0, 0. So my key points will be, if I add 3 to the x value here, moving to the right 3, that's going to give me the point 3, 0. If I subtract 3 from the x value, that's moving to the left 3, so I get negative 3, 0. And if I'm moving up or down, well, I'm going to add or subtract 3 from the y value. So that's going to give me either 0, 3 or 0, negative 3. So what this is actually giving me is 4 what we call key points on the circle. So the easiest points to find from using the center and the radius of the circle. Okay, so with that in mind, now that we have those 3 points sketched in, we can actually make a nice little sketch of the circle. So I'm going to draw it in there. There's our sketch. And in this particular case, to find the x and y intercepts was actually quite nice. We can actually read them right off of our graph. So our x-intercepts are going to be at 3 and negative 3. And the same thing with our y-intercepts. So we take a look at our graph here, or the points we already calculated. Y-intercepts at 3 and negative 3. Okay. So I'll do B with you, because B gets a little bit more complicated. It's not centered at the origin anymore, but centered somewhere else. So I'll run through B with you, and then I'll let you try C on your own. Okay, so let's take a look at B. Okay, so if you want to take a look at B here, again, let's take a look at our center. So our center here, remember it's x minus hl squared plus y minus kl squared. So if it's x minus 4, that means the x value of my center is at 4. The y value is actually going to be at negative 2. So I would have y minus negative 2 all squared to get a y plus 2 inside that bracket. Okay, the radius, well, according to this, r squared equals 25. So what positive number squared equals 25? Well, it's going to be 5. Okay, so this equation has a center at 4, negative 2. So I'll just do a quick little jot of it there, and a radius of 5. So with that in mind, if the radius is 5, my center is down here at 4, negative 2. If I go up 5, right 5, down 5, and left 5, I can get 4 other key points. So how do I go up, right, left, and down 5? Well, I look at the coordinates of my center, and I go up, right, left, or down 5 from there. So that means adding or subtracting 5, the radius, from the x value, or adding or subtracting 5 from the y value. So let's take a look at the x value first. So my key points, 4 plus 5 is 9. So I have 9, negative 2. 4 minus 5 is negative 1. So I have negative 1, negative 2. With the y value, if I add 5, I'm going to get 4, 3. Now I subtract 5, I'm going to get 4, negative 7. And those should make sense when I try to put these key points on a graph. So I have the point 9, negative 2, negative 1, negative 2, 4, 3, and 4, negative 7. So these points should look like they make the nice points for the outside of a circle. And lo and behold, when I make my sketch for part 3, I mean, I didn't draw it the best by hand there, but it is going to be a circle there going through those 4 key points. Okay, so there's my sketch. Last but not least, I need to find the x and y intercepts. I can sort of see those x and y intercepts on my grid, but I can't necessarily get them exactly unless I solve for them. So one thing to remember about your x and y intercepts is, let's say we're trying to find the x-intercepts. Well, back in grade 9, or even in grade 10, you're trying to find the x-intercepts. What does that mean? It means y equals 0. So if we sub that into our equation, we're going to get x minus 4 all squared plus 0 plus 2 all squared. So I'm letting y equals 0 because I'm looking for the x-intercepts. And that's going to be equal to 25. And what this allows me to do now is actually rearrange this equation to solve for x. So x minus 4 all squared, I'm going to leave that for now. Okay, 0 plus 2 is 2, squared is 4. So I get x minus 4 squared equals 25. I'm going to move that 4 over, because I'm trying to isolate for x here. X minus 4 all squared is equal to 21. So now to get rid of that square, I take the square root of both sides. So I get x minus 4 equals plus or minus root 21. So that means x equals plus or minus root 21 plus 4. Okay, and I can turn these into decimal equivalents if I like. I'll do that in my calculator. Let's see what we get. Okay, so when I run both answers through my calculator, root 21 plus 4 and negative root 21 plus 4, I get these two possible answers. Even though my sketch isn't to scale, it sort of seems to fit approximately what those values might be. Now, maybe this negative 0.58 looks a little bit off, but again, my sketch wasn't the best. Okay, let's see. If we want, we can take a look at Desmos and actually confirm that, but these are the correct answers. So if I want to find the y-intercept, it's a similar process, except, of course, now I'm going to let x equal to 0. So if that's going to be the case, I'm going to have 0 minus 4 all squared plus y plus 2 squared equals 25. Okay, 0 minus 4 is negative 4, squared is 16. Which, when I subtract 16 from both sides, gives me y plus 2 squared equals 9. So when I take the square root of both sides, now I get y plus 2 being equal to plus or minus square root of 9, which is 3. So I get y equals plus or minus 3 minus 2. So that tells me y equals positive 3 minus 2, which is 1, or y equals negative 3 minus 2, which is negative 5. Okay, that gives you my two possible y-intercepts. And again, sort of fits with my rough, crude little sketch up here. So the one thing I want to point out here is it actually is possible to create a circle, like for example this green one I just draw right here, that has no x or y intercepts. If that is the case, when you try to solve for them, because you might not necessarily have a sketch in front of you, when you try to solve for them, you're going to recognize here they're going to wind up somewhere with a negative that you have to put underneath the square root, which is impossible, right? So just like when you're solving a quadratic equation, you get a negative value for the discriminant, so a negative value underneath the square root. That tells you have no solution. Same thing here. If you're trying to solve for a particular intercept, x-intercept or y-intercept, you wind up with a negative underneath the square root at any point. That's the math's way of telling you there's not going to be any x-intercepts or y-intercepts depending on what you're trying to solve for. Okay, so with those two done, I'd like you to try doing C on your own. So x plus 5 all squared plus y squared. When you finish finding the center, radius, the other key points on the circle, doing a sketch, and finding the x and y intercepts, push play and ready to go through the answer together. Okay, so you can take a minute here and check your answers. So I got for the third one a center at negative 5, 0, and a radius, because r squared equals 16, r equals 4. Because my radius was 4, I found other key points by adding or subtracting that radius to the x and y values of the center. So that means I got points at negative 1, 0, negative 9, 0, negative 5, 4, and negative 5, negative 4. Because these 2 points here, negative 1, 0, negative 9, 0, because the y value is 0, I have my x-intercepts at negative 9, negative 1. I could solve for them, but since they happen to be my key points, I just took those. For the y-intercept, you can see from the graph there's going to be none. Now, to show algebraically what's going to happen if you didn't recognize this or you didn't have a graph, if you put in x equals 0 into the equation and try and rearrange for y, you wind up at some point getting the equation y squared equals negative 9, which has no solution. So as I mentioned before, what this is telling you, it's math's way of telling you there's no solution, so there's no y-intercepts. Okay, so hopefully these ones worked out. If you're so we're going to take a look at example here in example 4 in part 2.